This is Connor with the ET100.
And Aniela.
And Jarod, and today we'll be talking about the RLC circuit at resonant frequency. So the way to calculate resonant frequency is by using the formula is 1 over 2 pi times the square root of L times C, which would be inductors and capacitors. So in this particular circuit, we calculated that as 1,591.55 hertz, which was rounded off to 1.6 kilohertz. Um, so when a circuit is at resonant frequency, that means that its inductive reactance and capacitive reactance are equal. So in this case, we calculated those were just 1,000 ohms each. So they're canceling each other out. Neither one is bigger than the other. And then our resistance is equal to Z, our impedance. So with all of that, off to Connor.
So I'm just going to quickly go over what the circuit is again and what it does. This is a bandpass circuit, which is used in radios and stuff. Like when you use the dials to zero in on specific radio stations, it kind of cancels out all the other frequencies from other stations. So that way you don't get like overlapping sounds and stations and whatnot. So pretty common application. Pretty common application. Uh, yeah. I'm gonna pass off to Aniela real quick.
All right, I'm going to talk about a little fun fact of way of memorizing the circuit. It's called Eli the Iceman, and Eli stands for electromotive force that leads current, and the Iceman part, I stands for current leading voltage or electromotive force. Um, we also did a fun little thing with finding the temperature. We did the current times voltage times time, which we did in seconds. We did 0.005 amps times 5 volts times 1 second, which gave us 0.025 joules. We took the 0.025 joules and converted that to Celsius, which that converted to 0.00001316 degrees Celsius per second, which is not very much heat that's being given off. And now back to Connor.
The last thing I'm going to talk about is phase shift, which if you look at the inductor or capacitor in an oscilloscope, you'd see that there's, or if you're looking at the voltage and current, you'd see that they're not lined up, or like they're not exactly overlapping. If they were overlapping, they'd be perfectly in sync. And then if you look at the uh, conductor, or not conductor, capacitor and inductor, you'd see that they're completely out of phase. They're always going to be 180 degrees out of phase. The inductor will always be 90 degrees. The capacitor will always be at negative 90 degrees. They're polar opposites of each other. So yeah, that's pretty much everything we have to talk about. Thanks for watching. Hope you enjoyed. Hope you learned something. Bye.